Welcome to Mind Stretch. Today, we're delving into the fascinating world of chaos theory, the branch of mathematics that reveals how tiny, almost imperceptible differences in initial conditions can create enormous, unpredictable effects. If you've ever wondered why weather forecasts go off track or how a minor miscalculation can cause a system to spiral out of control, buckle up for a look into the science of chaos. Chaos theory is often summarized by the metaphor of a butterfly flapping its wings in one part of the world and triggering a tornado in another. While it sounds poetic, the essence of chaos theory is deeply mathematical. It studies complex systems like the atmosphere, ecosystems, or even the stock market, and shows how they can be incredibly sensitive to their initial conditions. This sensitivity means that tiny discrepancies can rapidly multiply over time, making the system's future state extraordinarily difficult to predict. Unlike simple, predictable phenomena, chaotic systems act in ways that seem random, but are actually governed by very precise rules. The story of chaos theory begins largely with meteorologist Edward Lorenz in the early 1960s. While running weather simulations on a primitive computer, Lorenz noticed that rounding just a few decimal points in his data led to vastly different forecasts. This realization was groundbreaking. It revealed that complex systems like weather are so sensitive that minute changes, like rounding from 0.506127 to 0.506, could alter the entire system's evolution. Lorenz's discovery challenged the long-held assumption that, with enough computational power, we could make perfectly accurate predictions. Instead, it showed that beyond a certain point, forecasts become chaotic and impossible to pin down precisely. One key tool in chaos theory is the concept of strange attractors, patterns that arise in a chaotic system but never repeat exactly. Lorenz discovered a famous example, now known as the Lorenz attractor, a butterfly-shaped pattern that illustrates how a system's trajectories can diverge wildly even when they start very close together. Another fundamental concept is fractal geometry, introduced by Benoit Mandelbrot. Fractals describe repeating patterns that look similar at every scale. Many chaotic systems exhibit fractal behavior, revealing hidden structures within what seems like randomness. By studying these patterns, mathematicians and scientists uncover some of the deeper principles that govern chaotic dynamics. Chaos theory isn't just about abstract mathematics. It has practical applications in numerous fields. In meteorology, understanding chaos helps forecasters gauge the limits of weather prediction and refine models for short-term accuracy. In biology, researchers analyze chaotic population dynamics to understand why animal populations can suddenly boom or crash. Even the financial markets show chaotic traits. Tiny shifts in investor sentiment can cascade into major bull or bear runs. By identifying chaotic behavior, analysts attempt to gauge risk and navigate market turbulence. While we can't always predict the exact outcome, recognizing chaos helps us grasp the underlying complexity. So, how can we apply chaos theory to our everyday lives? One lesson is mindful awareness of how small changes can magnify over time. A slight tweak in your schedule, a small adjustment in a project plan, or even a tiny shift in attitude can set off a ripple effect, drastically altering outcomes. Chaos theory encourages us to remain flexible and adaptive, acknowledging that while systems may be sensitive to our actions, they also offer opportunities for creative influence. Embracing the unpredictable aspects of life can spark innovation and broaden our horizons, reminding us that even the tiniest step can lead to a remarkable journey. Thank you for joining us on this deep dive into the world of chaos theory. We hope you've gained a fresh perspective on how small changes can cascade into large, sometimes monumental consequences. If you enjoyed this exploration, give it a thumbs up, share it, and subscribe to MindStretch for more exciting journeys into the hidden patterns of our universe. Until next time, remember that the slightest flap of a wing just might change everything.